Welcome to a new deep dive. Today, we're really getting into the weeds with KubeRocketCI, specifically focusing on something called a Codebase. If you're working with this platform, architecting, developing, deploying, understanding the Codebase is, well, pretty fundamental.
Absolutely. It's central. The KubeRocketCI Codebase is how you manage your actual source code within the platform. It's not just a link to Git, it's more structured. KubeRocketCI uses it actively for the whole software lifecycle.
Okay, so the docs make this distinction, right, between a business component and the technical code base. Can you break that down for us? What's the real difference day to day?
Sure. Think of it like this. The component is the what. What function does this piece of software perform for the business? A feature, maybe a microservice. The code base, on the other hand, is the how. How is that function actually built? It's a specific Kubernetes custom resource, and its job is to manage the link to the Git repository where the code lives.
I see. So the code base connects the business idea to the actual code in Git managed inside Kubernetes.
Exactly. It's that crucial technical translation layer.
Now, something that comes up early. Before you even create components, KubeRocketCI makes you add a Git server. Why that first step?
Well, it's foundational, isn't it? A code base, by definition, deals with code in Git. So KubeRocketCI needs to know which Git server, where does this repository live?
Yeah.
You can't really define the how the code base without first telling the platform where its home is.
Like needing the address before you send the package? Makes sense.
Precisely.
All right. So our mission for this deep dive then is clear. Let's really understand the different types of code bases available in KubeRocketCI and also the ways you can actually get your code into the platform. The goal here is for you listening, maybe you're a DevOps engineer, an architect, a developer, to walk away with a solid practical grasp of this concept, whether you're driving, coding, whatever.
Sounds good. Let's start with those types. KubeRocketCI offers 4 main kinds of code bases. Each one is sort of tailored for a specific job in the development process.
Okay, 4 types. First one is application. Sounds like the main one.
It really is.
Yeah,
application is the most common type you'll encounter. It's your basic deployable unit. It contains the application source code, naturally, but also the Kubernetes manifest needed to actually run it. Your core logic lives here. And, importantly, it supports a whole range of languages, frameworks, build tools, so it's flexible. You can usually fit your existing stack in there.
Okay, so that's the heart of the application. Got it. Next up, library. What's the purpose of a library code base?
Think shared code. A library code base is for holding those reusable pieces of logic that multiple projects might need. Could be other applications using it, could be Autotests, even other libraries. Imagine like standard logging functions or maybe data validation routines.
So you build it once, use it many times.
Exactly. Build it, test it well, then share it. It promotes consistency, saves a ton of time, reduces errors. It's about efficiency. Just note though, a library itself isn't deployed like an application. It just holds code to be used by others.
Right, avoids reinventing the wheel. Good stuff. Okay, moving on to Autotest. This is clearly about quality assurance.
Spot on. The Autotest codebase is specifically for your automated tests, performance tests, reliability checks, functional quality gates, that sort of thing. What's interesting here is how they're used. They aren't deployed into environments like applications are. Instead, they run after an application deployment. They act as these automated checks, these quality gates, to make sure everything's working as expected before maybe promoting further.
So they're the gatekeepers ensuring code quality post-deployment. Okay, and the last type, infrastructure. Sounds like managing the environment itself.
That's exactly it. An infrastructure codebase is used for defining and managing your project's infrastructure, using infrastructure as code IAC. Think Terraform, for example. You'd manage your Terraform code within this type of codebase. The whole point is treating your infrastructure setup like code. Version control it, automate it. This ensures consistency, reproducibility, and cuts down on manual configuration errors.
Okay, great overview. 4 types. Application, library for reuse, Autotest for QA, and infrastructure for IAC. Now, how do we actually get our code onto KubeRocketCI using these code bases? You mentioned 3 onboarding strategies. Let's start with create from template.
Right. Create from template is perfect if you're starting a brand new project, or maybe you just want to align quickly with KubeRocketCI's recommended structure. With this option, the platform basically generates a new code base for you using a pre-built template. These templates match specific tech stacks, language, build tool, framework, There's a variety available. So you get a basic project structure, maybe some boilerplate code, all set up. It's like a quick start kit.
A ready-made skeleton aligned with the tech. Cool. What about the second strategy, import project? How does that work for existing code?
Import project is your friend when your code already lives on a Git server that you've integrated with KubeRocketCI. So let's say you've connected your GitHub or GitLab instance. You just pick that server, select the repository you want to bring in, and KubeRocketCI essentially grabs it, replicates the necessary info, and sets it up as a code base within the platform. It's super useful for teams that have established projects and want to start using KubeRocketCI without messing up their existing Git history or workflow.
Right, a smoother path for code that's already managed somewhere integrated. Okay, and the third one is clone project. What's the difference there?
The key difference with clone is flexibility on the source. Import needs that pre-integrated Git server. Clone, however, lets you pull code from pretty much any Git repository accessible via HTTPS. You just give it the URL. KubeRocketCI then clones that repo and sets it up. This is great if the code is on a different Git provider, maybe a public repo you want to fork and customize, or even a private one if you provide credentials.
Gotcha. So import for integrated systems, clone for anywhere else accessible via HTTPS. Provides good coverage. Let's touch briefly on versioning. Code-based versioning. What's the main idea?
Yeah, versioning is just about having a clear way to identify and manage different builds or releases of your code. KubeRocketCI has a couple of approaches. The default way usually tags your container images using the branch name and a timestamp from the build. It gives you basic traceability.
Okay, base traceability. And the other one was SIM. How's that different?
Right, SIM stands for Semantic Image Management. This one tries to create more meaningful tags based on semantic versioning. It uses a format like application version.pack.build number. This is really helpful if your team follows Semver, as it gives you a much clearer, human-readable way to track versions and understand what's in each build.
A more structured, standard approach to version tags. Makes sense.
Oh.
Okay, last piece of the puzzle. The Codebase operator. What does this component actually do?
The Codebase operator. It's really important. It's the controller, the orchestrator for all these Codebase custom resources we've been talking about. When you create a Codebase in KubeRocketCI, you're actually creating an instance of this Codebase Kubernetes resource. This resource definition holds all the key info: name, description, type, application library, etc., the Git repo URL, branch, path, maybe CI/CD tool info. It's the blueprint.
So the Codebase resource defines what you want.
Exactly. And the Codebase operator is the thing that makes it real. It constantly watches these Codebase resources. If you change something, say you update the target branch in the resource definition, the operator sees that change, then it acts to make sure reality matches your definition. It synchronizes with the Git repo, updates related KubeRocketCI components. It's the automation engine ensuring everything stays aligned.
Got it. It keeps the definition and the reality in sync automatically.
Precisely. It handles the background work.
Okay, let's try and wrap this up. So Codebases are fundamental in KubeRocketCI. They're the technical side of a business component tied directly to a Git repository. We've got 4 types: application for deployables, library for shared code, Autotest for QA gates, and infrastructure for managing infrastructure as code. And getting code in 3 ways: create from template for new stuff, import for existing code on integrated Git servers, and clone for pretty much any other accessible Git repo.
It covers the main strategies, yes.
Plus, there's versioning to track changes, and the whole thing is automated by that Codebase operator working behind the scenes with the Kubernetes custom resource.
You've got it. Understanding these pieces, the types, the onboarding, the operator, is really key to leveraging KubeRocketCI effectively. It lets you focus more on the code itself.
So for everyone listening, the takeaway is maybe to think about your own projects. Which Codebase type fits which part? Which onboarding strategy makes the most sense for you right now? Getting a handle on this concept really does unlock a lot of the platform's power, and definitely check out the KubeRocketCI docs for the deeper API details on the Codebase resource itself. Thanks for joining us on this deep dive.